My name's Stan Sawalki. I'm the manager of architecture and engineering at PHFA. And some of you may know in 2015, PHFA started awarding points in our ranking application for building to passive house standards. Building to those standards is difficult in new construction. These folks chose to do it on two projects where 30% of the square footage was an existing old school building. It presented all sorts of additional complications, and that's basically what they're here to talk about. I have Laura Nettleton, who's an architect with the firm Thoughtful Balance, Phil Ford, who's the Vice President of Soto Construction Services, and Victor Rodriguez, the President of A.M. Rodriguez, the developer. All three are from Pittsburgh, and they're here to tell their story about
And we're still
Morningside Crossing and Glassport Senior Housing.
And we're still here to tell the story, although just barely. So,
Oh, wait, I'm supposed to read this.
okay.
Before we begin, we wanted to let you know that this session is being videotaped. There's a single camera in the back of the room. The video of this session will be made available to forum attendees after the event. If you do ask a question during this session, there's a chance that you may be seen in that video. Just wanted to make you aware of that.
Big Brother's watching.
So it takes a village to make a project like this. This was our village. And Victor, I'm going to let you start and talk about our team.
So, yeah, Soto Construction and A.M. Rodriguez Associates began working together in the early 90s, and we started our first project with a school rehab in Carnegie, PA. And since then, we've worked on a lot of projects, and Laura Nettleton and Thoughtful Balance came into the mix. It was about 2007 when we did a rehab in Moon Township, which is up there in the middle left-hand side, and then in the middle, kind of next to that, we did a school project together on Mount Washington in Pittsburgh, and we've worked on a bunch of different lead projects prior to these passive house. We're always kind of trying to do new approaches to saving energy, and you know, we've always looked at the best ways to approach that. We received some grants from the Pennsylvania Energy Development Authority. One of them was for solar panels on our South Hills High School, and a cogeneration unit that produces electricity on site through a gas-fired turbine. Those had a lot of complications because there's a lot of moving parts to them. So we started looking at different ways to do things, and with the incentivization of passive house, really it should be a lot simpler building that's just very well insulated and airtight, and have mechanical systems that our maintenance staff can maintain a lot easier. And this is what we're going to look at today is these two passive house retrofits of two schools. Glassport was an elementary school in the borough of Glassport, and Morningside is in the neighborhood of Morningside in Pittsburgh. Two distinctly different schools. Morningside was a school that was built in the late 1800s, a typical school that had the central stairway going down the middle, which was the kind they stopped building in the early part of the last century because of the fire hazard with those schools. We've done a lot of school rehabs. My father was an architect, and he kind of trained me what schools to look out for and what ones to avoid. Morningside typically would have been one we avoided, but there is such a big political push to get that school saved because architecturally in that neighborhood it was very significant. And so we decided to try to make this passive house retrofit work with a Morningside school, which is mostly what we're going to talk about, but we're also going to talk about Glassport. That school was constructed in 1933, which was more of the style of school we like to use for apartments, converting to apartments. They had the right classrooms and hallway widths and just layout in general that we look for in schools. it's definitely, it's one of the first part of the process is looking at schools as to how well they convert to apartments. And now with Passive House layered on there, we always want to look at, are we going to cover the outside, the inside? A lot of these schools we did already have such important architectural elements that we can't cover the outside of them without really ruining the fabric of the neighborhood. So without further ado, I'll pass it back to Laura.
My firm, Thoughtful Balance, has been interested in sustainability and particularly in energy for a number of years. And one of the things that we've realized is kind of the magnitude of the challenge that we have in front of us when we look at the relationship between our existing building stock and climate change. And if we think about New York City hitting 2030 targets, we need to start renovating today. And actually, this slide is about a year old. So at the rate of 162 buildings per day. So our challenge is great. And over the course of working with the Rodriguezes, Soto Construction and AMR and ourselves have looked at energy in the buildings that we've done. And Passive House, by far, gave us the biggest opportunity to really make significant savings. Now, it's important the way we like calculating as a team savings is through a measurement called EUI, energy use intensity. And that EUI is like a miles per gallon figure that can be applied to buildings. So we can, as consumers, begin to compare one building with another. And we don't really have that metric yet in place, but it's an easy metric to make. It's conditioned square footage divided into annual energy use, and you come up with a number, and that number you can see in our projects over time has come down relative to air tightness. Now, the 18.5 that we're showing on Morningside is important to note. We don't have an annual projection of energy yet, so that's a modeled prediction. That's where we think we're going to be. It's not necessarily where we are. I think that the fit in thinking about retrofits with affordable housing is really a good one, because in our community we have a lot of buildings that have a social stigma. We don't like the stigma that they had. Pruitt-Igoe, we tore it down even though it had excellent quality materials and a lot of embodied energy, and was probably made out of better materials than we can afford today, but it had such a social stigma that we felt the need to raise it. And we'd like to really offer a thought about how we can change that paradigm in buildings today using Passive House strategies. When we did this project together, which is an old school South Hills retirement residence, we calculated the embodied energy that exists just in saving the shell and the footers and the floor slabs and the roof structure. And the energy that was embodied in that was equivalent to 5 gallons of gasoline per square foot. And that's not, guys showing up at the site and their trucks. That's just in the manufacturing of those materials. So when we're thinking about existing buildings, embodied energy really matters. In addition, in this project, we were really concerned with air quality. We started to realize when we were working on Passive House projects that if we were making a building airtight, so we weren't letting poor air get inside, and we were filtering that air and delivering a fresh stream of it every 3 hours, that we were actually creating the conditions for superior air quality. And we all know that we're serving underserved populations that are at risk for poor air quality, frequently due to inadequate heating devices. People are heating their residences with their gas stoves or with old kerosene heaters, and that creates health issues. And I would say that our team always starts with community and stakeholders. And again, I'm going to defer to Victor and talk about that. But these two projects were no different.
Yeah, so as I was saying with the old schools and the architectural details of these schools, and one was actually a good reuse, easy to reuse glass board, and one was tougher, the Morningside, we had to spend a lot of time with the community and understand what they wanted out of these retrofits. Morningside is the middle of this neighborhood, and it's an old, working class neighborhood, but it's always been pretty solid in Pittsburgh. And one of the things they wanted was to create a plaza. They had a comprehensive plan of their neighborhood, and they wanted to create a plaza right on the corner there. So we ended up tearing down part of a wing of the building that was added in the 80s. It wasn't very attractive, so it was easy to say, hey, we're tearing this down. And through that process, we tried to create, programs and understand what they wanted. And one of the other things they wanted was a senior center, which was in a corner of the neighborhood in a really dilapidated kind of old building. They wanted to move it to this housing project. And so part of the innovation and design, which is what that was for 2017, was not only do a passive house project of an old school, but to bring this senior center in and create extra services where we have, meals and activities on site. And they're trying to open up the community center to more generations than just seniors. That's what they're calling an active living community right now. So that's what we got from the whole process of working with the community.
So this is the neighborhood that that we're in. We have Greenwood Street, which is one of the main commercial streets in Morningside, and then we're on Jancy Street. That's our school, and so we're really located in the heart of that neighborhood.
Yeah, you can see the plaza up there to the top left, which just got finished not that long ago. So there's a lot of programming with that. There's a neighborhood resident who sells Christmas trees in the wintertime, and they're trying to come up with different ways to bring the community together. So it's like a new focal point in the neighborhood.
And I would just add to that this is a new construction piece which sits over where there was an empty lot. This is the 1897 school, and this is the 1927, 9 edition.
Where the senior center is, yeah.
Where the senior center is.
Yeah.
And there are some thoughts about how we could use the plaza. And we tried to fit it into, there's a smaller scale in the neighborhood that this fits into, and we wanted to break up that scale from an urban design point of view. So I think, as Victor was saying, we had the community center, and we were looking at multi-generational opportunities in the community center. We were thinking about the impact that the structure would have on neighborhood renewal. And one of the things that we agreed to in the application was to look at these 3 distinct parts of the building and then be able to monitor each one in terms of its performance, and each one would have its own construction type. So you have to realize this was in one of the early rounds of Passive House for PHFA. So we were looking at existing construction versus new construction, and one where we were insulating largely from the outside, one where we were insulating largely from the inside, and then looking at those in juxtaposition to new construction. We're just starting to get information back from that, which is exciting. And then, of course, we were, because of the issue with air quality in vulnerable populations, we agreed that we would monitor the air quality as well. One of the reasons that air quality is important, you drink 3 to 4 liters of water a day, but you breathe 15,000 liters of air per day. And I don't think that I remember to include it in this slide, but I had a little experiment in my living room where I took a floor fan and I taped a MERV 13 filter on the front of it and just blew air through it. And I was told that would actually, and I had a particle monitor in my living room that I was looking at indoor air quality. Pittsburgh has just gotten an F as a score for air quality nationwide. We're the worst city outside of Los Angeles in the country. And it's something that we can't really control because we have microfine particles that are blowing in from states like Missouri and Indiana. But I ran that, and I'm sorry I didn't bring it today, I ran that floor filter for 6 months in my house, and I have a photograph of a brand new white filter next to what is essentially a black filter. And, that's our lungs when we're living in those conditions. So one of the things that we were able to monitor is CO2, which affects your cognitive performance. So people who are in schools, people who are in dwelling units, people who are in office buildings, really pay attention to that particular reading in air quality. There are VOCs, which relate to the materials that are put inside, so materials that off-gas. We all know that from LEED. And those are things like paint and adhesives, mastic for tile, and furnishings. And the way we've been thinking about it in the industry that we really inherited from LEED was we had a flush-out phase, and we would measure the quality of the air after the flush-out phase. But what we started realizing as a community was that we'd get good scores when we immediately had the flush-out phase. We were flushing out the building with air. But after that, when we went back in and started occupying it, the numbers for all of those CO2, VOCs, and particles all started climbing up. And so we realized that the flushing out wasn't the right approach. So particulate matter, one of the things that we worry about in Pittsburgh is that we have something called PM 2.5. And that's very, very tiny particles. And those tiny particles, when you breathe them in, they can enter your bloodstream. And they're linked, and the Heinz Foundation is doing a study through a group called GASP on the relationship between cardiac disease, stroke, and pulmonary issues in the Pittsburgh area. And they're finding that we have an elevated risk due to the particles that are entering our bloodstream. So particles are important too. And those particles are everything that you find from those manufacturers in those polluting states down the way. So we put in Morningside a dashboard, and it's kind of hard to see, but those are the metrics that we're looking at. We're looking at particles, CO2, VOCs, and this was a really relatively inexpensive thing to do. This was not high tech. We can look at it on our phones. And then we were comparing the inside air with the outside air. So I think that I just want to really quickly go through these slides. This is the building as it stood before we started construction. You can see that we had an empty part of the site down here. And I'm just going to quickly kind of click through the slides so you can have a sense of how complex a job this was. Unfortunately, we don't have our architectural photographs yet, but these are some of our nearly completed project. We've almost got the skin on the community center. We're capturing our rainwater on site, which is a big issue for Pittsburgh, and these are some of the almost finished interiors. And Phil can talk to us about some of the challenges we had in construction.
Yeah. Which one's my laser pointer?
The laser pointer is
The red button. Okay. So with this project, and especially obviously the renovation side, it presented a number of major construction challenges for the project. Victor had mentioned before that in the school itself, there was 3 renovations. There was the 1897, the 1929, and the portion that we took off. But even within the initial construction alone in the 1897 building, if you would go from different classroom to different classroom, you would find different window jamb construction of how they installed the windows, whether from a masonry, wood, and a mixture of the two of how they actually constructed and installed the windows. So going in for the application, initial design, and PLI permitting, we had a main assumption. We did some investigative work thanks to the URA and the school board letting us get in and kind of do some demolition to investigate how we wanted to do things, and had a plan of what we were going to do. Once we got into the project and we actually got into demolition, we realized that that plan really only applied to the windows that we more or less investigated.
once demolition had really gotten through, we had on one floor in 4 classrooms, we had, I think, 6 different scenarios of how a window was initially installed there, which changed how we were going to retrofit them and get the new passive house windows. We used a clear wall window and plywood bucks to get our passive house seal. So we really had to go back and figure that out. So from a construction standpoint, we had to spend time both with the architect and the window designer, and then us at Soto as well, to come up with more or less, it was a 12-page submittal of different types of jams and various ways that we would need to install, and that was just to really get the process started, and then could agree on, you know, the overall size of the windows that could come out and get things moving in that regard. So it was a big heavy hurdle right out of the gate. So we kind of went out there and said, okay, now we're really into it. One of the other interesting details was the way some of the different floor systems and walls were installed. You can see kind of in this detail here. We had the steel and concrete floors would come back on the other side. We had a plaster ceiling that was wasn't actually slated to be demoed, but once we got into it and realized that we had to give a full air seal on the project, we had to cut 3 feet back all the way around in each of the units, and this will be important when I get into the blower doors later. That we cut a portion all the way around through that, and then the intent was to use a closed cell spray foam insulation all the way up the perimeter of the wall and coming back 5 feet to establish that air seal. Now we were still going to have some leakage in the slab itself going through the exterior wall that was pretty much unavoidable unless we, you know, dipped the whole building in something. But we more or less used that approach and figured that would be a reasonable both air seal and barrier that we needed to accomplish our testing. So the red line that you see here is basically what is being denoted as the air barrier, which in our case was utilized both as the insulation layer and the air barrier with the closed cell spray foam insulation. Other surprises that we came in some cases we had floors that were a cast-in-place concrete floor that were board formed. In other situations we had terracotta tile with sleepers in between and steel with ran through them. And basically we would open up the terracotta, and these locations were going to perpendicular to the exterior wall. So you had open cavities through this terracotta floor system that would reach the exterior wall and could potentially pull in air through any blower door tests that were being basically ignored. If we would have spray foamed all the way up and then did our typical 5 feet in here, you would have had a complete open cavity in between that and the next level floor. So we had to go through along the exterior perimeter wall wherever we had this instance and basically break out the lower section of these terracotta tiles and expose that cavity, and then fill that with a spray foam as well to not allow that air travel to come in from the exterior to the interior. So it was very much a work in progress as we continued to demo and understand kind of the situations that we were getting into throughout. Here's some more pictures of that. It's kind of where you can see everything broken along that exterior wall. So that was a very critical concern for us the whole way, leading into what we're going to get into now is the interim blower door testing, which is always the make or break in a passive house project. Was we had so many intersecting walls in this project, and we knew to an extent what we were getting into initially, but it quintupled when we got in there. There were so many different ways that the building was constructed that we were thinking on the fly and trying to determine what's the best way to air seal this building as we got into it more and more, and it became, you know, more or less a professional hodgepodge of this is what we're going to do at these locations. Okay, here's the new situation, what are we going to do here? Here's the next situation, what are we going to do here? And that was in coordination with Laura and her team, the passive house rater on the job, and the consultants as well, all kind of working collaboratively to come up with some decisions. So when we got into the time for interim blower door test, we had lopped off a gymnasium, and we were still working out the more or less design of the front of the community center and trying to figure out how the new met the old and establishing some of the existing steel and tying it all in together. But the rest of the project was still moving forward full steam, and we had a schedule to meet. So we had to make a basic decision of we need to get into drywall on this project if we're going to keep schedule and not risk any downward adjusters at the end of the project and get this project done. So how are we going to get to a point where we can get some representative interim blower door test? You know, in a perfect world on a passive house project, you want to complete the entirety of the exterior skin. You want to get all your windows, doors, everything complete as much as you can prior to drywall, pressurize the building at 50 pascals and understand what your leakage is. And then you can start to make some adjustments, whether it's using fog machines or different kinds of products to make sure that you're getting to the level that you need post drywall, because it's much more difficult after the drywall is installed. So what was decided was we would basically cordon off the entirety of the community center. If you can remember from the picture, it was the one on the left. And even though the wall in between the two portions of the building would eventually be inside the passive house envelope, for the time being, we had to more or less do our best to seal that off. So if you can imagine areas where old HVAC was above the ceiling, wasn't there, was now a piece of rigid insulation with some air sealant and some spray foam. We added all kinds of little spray foam areas. We were using for Soto. We were trying to zip tape things all over the place to try and keep the air from coming in. The result was, on the first blower door test, which was at the beginning of December midstream on the project, was an absolute failure. We couldn't even bring the project up to pressure, which at this point was all I wanted to do. If we could get up to pressure, then we could at least see where the major leaks were. We could make an educated guess and move things forward. So that wasn't really attainable. So we had basically sealed off either side of the building with plywood or drywall and spray foam and said, okay, now let's pressurize the building. And it didn't work. So first we went in and tried to figure out where we could attack these areas. We added some spray foam. We did some more taping. We used thermal imaging cameras. Luckily, it was December, so it was cold outside. We were pumping heat inside the building, and we did have a whole bunch of closed-cell spray foam, so we could get a nice temperature differential to try and track where the air was coming in at to an extent. And so we tried to kind of spot attack the areas the best we could. The result was it still wasn't enough. So we had to go in, and I came up with the idea. I said, hey, let's go in and let's compartmentalize the units. So Laura and I got together and said, if we can cordon off each of the units, let's move the schedule forward so we can get all the units done. We can fall back on the common areas later and get those done near the end, but we need to have a representative data for at least the units themselves that's going to show that we're stopping this airflow from coming in. So that's where we switched gears, which was the first of 3 more interim blower door tests that we did individually on the units. We went through and sealed up all of the sleeper studs behind the plaster. And by the way, the plaster was a great air barrier inside the building. We were getting no leakage from the thick plaster with the paint that was being concealed behind the drywall, but all the little nooks and crannies and areas here where this is where the chalkboards used to be attached to the back of the wall, we were just feeling the cold air coming through. So it was traveling somehow from the exterior masonry, coming into the studs that were buried inside the masonry wall that were there to affix the chalkboards to, and sneaking its way through in a large blast of cold air. So we used 1 part can foam, thinking, okay, that'll get us enough, we'll take care of that. And we ran through and did all that. And then additionally, we were getting unit-to-unit communication in some of the fly ash here, so we went through and got spray foam throughout the side, on either side there. So the first test that we did at this location was somewhere around 1,800, give or take CFMs at the level that we needed. And that wasn't anywhere near the levels that we were projecting that we needed to be at. By the time we went through the second time, it had gotten us down to about 1,400. So we got about 400, but we were trying to get sub 1,000 on the area. So we still had some long ways to go. So we went back through thermal imaging cameras, checked and see where leaks could be, and this was the ultimate result. Where we had cut back the 3-foot section away from the wall, somehow, some way, in the ceiling plane above or in demising walls that were inside the passive house envelope, the blower door was pulling in air through the either exterior masonry or in between the floor slabs or from God knows where throughout the project. And it was sneaking its way back up through the ceiling and then coming out through the blower door. So all the exterior walls and everything seemed to be sealing okay. We weren't getting any airflow from there. There wasn't any major blue marks on the thermal imaging cameras. Everything seemed to be sealed up the way that it should be. But we were still getting vast amounts of air from above the ceiling. So we went in an effort in every unit there where we basically broke the ceiling plane there through a mix of installing drywall or stuffing bad insulation and figuring out a location to basically get a nice solid spray foam layer to connect the ceiling plane down into there. And then I had my guys go through with little parts of can foam, and every single little hole that was in the ceiling from every tie from the old ceiling that was in there, or any light fixture or any old box. We had to seal up every last little hole because it was finding its way out, and it was impossible to get it any other way. So that's what we did for every unit, and we got it down to about 700 CFM. So it worked. That was the issue. We had to completely isolate it from the rest of the building. And that was a major success for us. So we moved into drywall and we moved things forward, and then eventually applied the same logic to the common areas with the hopes that it would work similarly. So that was the one. We were at 900, so that was probably around the third, give or take. So that's the interim. You want to talk about glass port?
Sure. Yeah, you can't talk about that. This is the other project that we did as a passive house retrofit. So we had a different contractor, Frandl Construction, do this. And you can see to the left there's a new wing, and to the right is the old school. And it's roughly around 50-50 as far as square footage on this one. This is the new entrance. And this was an easier project because it was all, the old school was all built at once. There was some changes that were done initially, and a non-passive house problem was that there was an auditorium in there where we had to rip out the whole floor and redo the floor. And we really couldn't figure all that out until we got in and actually started demolition. And that was a big unknown for us as far as just regular construction. We did run into some problems with the blower door tests, as you know, similar to what Phil did, where we had to go around and search for connecting walls in the school where they were, you know, transmitting air between units and both up and down and side by side. I don't know if you have more to add to that here, but
Well, I think what I would say is one of the things that I've learned is I would never approach a complex retrofit like this if I was insulating from the inside without an envelope consultant. I would never do it. There's too much building science involved, and it's too tricky. There are too many things that come up, and you need multiple sets of eyes on it, looking at it. If you insulate a building from the outside, no problem. You're just putting a sweater on it, and you can control those details. It's a piece of cake. But insulating from the inside, the way we did in these two projects, it's not for the faint of heart, and it requires a lot of commitment from everybody on the team. But also backed with that building science, which gives you a level of confidence about the moves that you're making and the materials that you're using. We've gotten a lot of pushback from people when we say that we're using spray foam, because spray foam isn't the greenest material in the world. And I've had a number of people say to me, why didn't you use fluid applied with Roxol? But none of the envelope consultants that I've had have felt that that was a good idea. They thought that using spray foam, they thought that that would lead to brick failure. And you're thinking about something, an issue that's major like brick failure. It's not something that I'm just going to wing a guess at. I really want someone that knows what they're doing, kind of guiding me. Perfect. So as you can see, this is the new wing. This is the old school. Because there were steps up, we made a new accessible entrance in the back. And over here, we captured all of our stormwater on site. These are some, again, we don't have finished architectural photography because we're not into spring. These are showing up much better on my screen than they are on that screen. You want to talk about taking the auditorium off, Victor?
well, that's the gymnasium picture.
Or the, I mean,
that's
yeah,
the
gymnasium.
there, which is another challenging one. When we started this project in Glassport, and that's another thing for people to be aware of, is that not all engineers are made equal. The original engineer, they wanted us to do micropiles down to bedrock inside the building, which would have been very expensive and taken a lot of time out of the project. This building is, they overbuilt these old buildings, and so we're just putting wood construction in this really durable building. Why are we doing this? And long story short, we had to basically fire the original structural engineer and find one who could work with old buildings, and they have all the old books where they can look at how buildings were built 80, 100 years ago. And that made all the difference in getting the project in budget, because before, I mean, it was like $1 million over budget with the approach the structural engineer was going at to basically protect their butt from whatever. I mean, that's the way the world is now, so.
These are pictures of the insulation going up on the places where the gymnasium was taken down, where we had scars on the outside of the building, adding a layer of peel and stick, and then a layer of foam, and then the final finished material. Just quickly run through those. We're almost finished. So people ask how much does Passive House cost? I was just having a conversation with a gentleman before we started. We did Morningside for $170 a square foot, and we were feeling pretty proud about that number. Glassport cost us a little bit more, $185. I think those were some of the structural challenges that Victor was just describing. And when we look at them I love these graphs because these are 179 projects that were presented in terms of their budgets in the 2015-2016 funding round. And the green dots are the Passive House projects. So when you're asking, does Passive House cost more, you can see that the Passive House projects integrate into the field pretty well. It's not like all the green dots are on the top. Do we think that Passive House cost us more in our projects? Definitely. Some of the hoops that we were jumping through, how could it not? But it's really important to understand that the basic strategy is that you're taking money, putting it into the envelope, and taking it out of the mechanical system. And what building owner and what architect doesn't like that? You're making a better building, you're making a more robust envelope that lasts for a longer time out of better materials, and the stuff that costs you money to maintain is reduced in size. There's a diagram basically showing that concept. So you're saving dollars both in the operating cost, in the cost of energy, and in not having to maintain such large equipment. I think one of the things that's really important, I don't know how many people in the room have done a Passive House project, but it's really important to remember that this is a system. So one of the challenges that we were facing when we were looking at, are we making our targets or not, is our mechanical system going to be large enough to handle the load that we miss it by? So it's a little bit of, it's a scary situation in a case where you don't know how you're going to come out. And so you need somebody like Phil on the team who's going to be really diligent about getting the air tightness numbers down. We missed our air tightness on both of these projects. I've never done a retrofit where I haven't missed the air tightness number. But the mechanical engineer designs a mechanical system that is 2 or 3 times greater and or can have an air tightness leakage that's 2 or 3 times greater than the Passive House targets recommend. You want to talk about where we spent our extra money? So we thought on Morningside, this is Morningside, we had a 2% increase in cost, which really isn't so bad. Now, in terms of gray hair and lessons learned, it might have been more.
I was giving Victor the good deal. Yeah, so we tried to overlay some of the areas that we did, and with the deltas above typical construction. For the concrete, we did a 4-inch insulation and an overlay in the areas because we had to build up the floors to get the insulation on the existing school concrete. For the metals, we had some thermal break fabrica pads that had to be designed for the thermal break, where the podium construction of the building went its way up.
Explain what that is.
So
It's one of the strangest things I've ever heard of, these fabrica pads.
So you have this structure where we've got this podium built up above a parking lot. So it's basically you're trying to thermally break and from an air perspective, break a building that's more or less being held up on the air by sticks, by the steel. And you need to find a way that steel, which is outside being communicated, doesn't transmit that cold air into a interior warm envelope, because you can have condensation issues, you can have performance issues, so you have to find something to break. There's a number of different tools that you can use out there, and one of them, the one that we used, was a Particulate pad. We found was the most cost effective in general, but it's an engineered pad. It basically looks like a big thick piece of green plastic that goes in between the beam on either end and sandwiches it, and then all of the steel bolts as well have washers on them as well that are made of the same material. It's structurally engineered and sound to carry all the load, but at the same time the temperature doesn't conduct through as much as it does. But they're obscenely expensive. This was for what was determined initially. There was actually, I think there was another slide in here. Yeah, so we ended up adding almost another 10 grand worth of them there. So we had, just for these pads, and there wasn't many, it was maybe 8 or 10, it ended up being around $20,000. But it was necessary. You couldn't pass the model, and you would have endangered the building if we didn't put them in. So we had another 50 grand in some flooring overlays and insulation, and then obviously the big number in any project is the added insulation. We had added roof insulation. We had podium insulation. Unfortunately, it's a lot easier. We have done a passive house project with no insulation on the floor slab, and the arguments were made, the models were ran on a new construction project. But in this case, given the fact that we were an elevated deck, we had to construct more or less a second floor system above our podium, which added a fair amount of cost.
And that was because we had units in the basement. It was not just at the podium, but it was also, we built a new floor. We had units in the basement, and the idea of seniors living on an uninsulated slab was too scary. So it was that wasn't so much a passive house issue as it was a thermal comfort issue.
Yeah, it was twofold for the interior of the building.
And notice that we're taking $110,000 out at the bottom for HVAC, which you can barely see. It's running off the slide.
You can barely tell it. And then obviously there was a premium for passive house windows versus what we would consider a standard window. Adds throughout the process. We added some added sealing at the window situation that we were at. We added a change to polyiso to more or less work the model. We had trade-offs in the model that we had to work with, so we had to change some insulation to get it to pre-certification. We did some insulated headers at the new construction building. We installed our spray foam in a two-pass installation to ensure a more adequate and robust air barrier, just for the fact that we went through with a 1-inch to seal everything up. We did an inspection with our rater and then went through with a second pass. But unfortunately, there's a lot more labor in setting up again and pulling all those hoses through. This was actually a great deal. I found out from our insulation contractor yesterday that he didn't figure out the calculation that when spraying 5 inches versus 4+1, you had a vastly different yield on the 1 inch. So he lost a whole ton of money on the material because the spray, the way that it works. So I told him he'll get the next job maybe. And then we had it added liquid flashing through the project. But yeah, in general, on this project we saw on the morning side with the change orders included about 4.5% delta from the standard building.
Yeah, I misspoke. I said it was 2. It was 4.5.
That's what it was on Hillcrest actually. For the new construction, it was like 2.1%.
So we wanted to say something about performance. We've only got really 2 good months worth of utility bills because we've been leasing up, so we've had properties that aren't full. And so we looked at the months of February and March when we knew we were coming here today. And because we can't calculate EUI, which I said at the beginning is really the ideal number that we should be using, because we don't have the cooling season yet. We don't have a whole 12 months that we can calculate an EUI with, and to do anything else would be too much projecting. So we looked at another building that we wanted to give you some sense of how they're performing and to know for ourselves. And so we looked at another building that Victor has in his portfolio that's called Duquesne, which I'll show you a picture of in a minute. But so Glassport is 55 units. Duquesne is 55 units. They're both retrofits of schools. Duquesne was done in what year?
1997. It doesn't have any new parts to it like Glassport. It's all retrofit.
So it's all retrofit.
Yeah.
But we looked at we looked at the bills. We included domestic hot water in these, so we calculated the MCF to kWh. And all of them are gas, domestic hot water, and electric heating and cooling, all three projects. So we can see that the energy usage in KWH in the two passive house top two projects are like, around 35 KWH. And we're looking at the one for Duquesne, 175,000 KWH. So that was really exciting. But we're not seeing that in terms of cost. And, I have missed this. This is like the big passive house puzzle, because when you save that energy, you should be saving that money, right? So why aren't we saving that money? And we looked at the number of bills that we're getting. And so we're getting 56 bills at Glassport, and I want to compare these two that are in yellow, Glassport because they're the same size, and Duquesne, 55 units. We're getting one bill at Duquesne, we're getting 56 bills at Glassport. 56 bills is because Duquesne Light is telling us that if you individually meter, you're actually encouraging people to track their own energy. Well, Victor pays the utility bills, so that argument should be lost. And in my opinion, for affordable housing, you should not be required to separately meter. You should be allowed to have one bill. But when you start to look at the bills themselves, you'll see on this bill, which is the Duquesne meter charges, you see that we have that monthly charge, and then you see the meter charges up there. When you look at the Morningside bill, this is one of 55 bills. You look at the meter charge, which is $12.35 compared to the unit cost of $66. So when we're comparing those in terms of meter charges, we're looking at the actual cost of energy, and we're seeing that it's about double at Duquesne. And we're looking at the meter charges, and we're seeing that there's just such a, we're almost 10 times the amount of meter charges. So what we're saving in energy, we're now paying in meter charges back to Duquesne Light under the guise that it's really greener, but I think it's actually a money grab on Duquesne Light's part. And I think we all need to petition them in terms of the pay structure for affordable housing.
Yeah, this is where I want to jump in here, because we need to work with the agency on this. Is it the Duquesne Light is going off a PUC ruling from 1982 or something. They never enforced it. So most of our senior housing is 1 meter. And then the first one we did was just a geothermal project in the borough of Plum Borough. We did this really efficient project of 58 units, and it was the first one we had to put in all 58 meters. And now we got a project that's saving on energy, but we're paying an extra $12,000 a year just in meter charges. And that project has struggled to really pay its bills only because of that reason, because these projects run really tight, as a lot of people know, in affordable housing. And so other places, I think there's other energy companies or energy utility companies like Duquesne Light that allow for a waiver, but Duquesne Light, we haven't been able to get that yet. So it's hurting our projects financially.
So we also wanted to check in on the Clear dashboard. Actually, if you put this URL in your phone, you can look and see what the air quality is doing at Morningside as we're sitting here. And if we look at the performance, I took this snapshot the other day. We can see that we're looking at particles, which are right around 5. We have good CO2. We have temperature and humidity, all that are in range. And you can see that we have occasional spikes. These are actually located in units. And so we're assuming that those spikes have to do with what's going on in the unit. Someone's cooking or cleaning or, giving us those intermittent spikes. Unfortunately, the outdoor monitor was down on this day, so I couldn't really compare the two, but I'm really anxious to be able to sort of track it over a longer period of time. So the residents that live at Morningside really love living there. And people say that about passive houses in general. People say, I haven't ever slept so well. I'm living in a relatively dust-free environment. My allergies have never been so good. I'm not using my inhaler anymore. Those are some of the things that we've heard and that we're really, really excited about. People seem to really love that building. And after all, people is why we're in this work.
Yeah, the Morningside is right on a bus line. I mean, it stops right out front of the building, so having a passive house project is really nice because they can't hear it or the exhaust from the bus doesn't come through and all that.
And the noise is a big thing, you know.
Yeah.
I mean, family or senior projects in general, but for seniors as well, that oftentimes have a hard time sleeping with the noise and everything like that. You know, we've heard nothing but great things about the people that have moved in. You know, we have 3 passive house projects to date. 2 of them are fully leased up, and only in one instance did we had a meeting with the residents at another project, Hillcrest Senior Residences, and one woman raised her hand and she said, "You guys said this was supposed to be quiet. It's so noisy in my apartment all the time." And the architect was taken aback and he said, "What are you talking about?" And after a bit of conversation, she said she liked to leave her window cracked at night. It's on the main Brownsville and Carrick router. But in general, I mean, it's amazing the sound differential in comparison.
So every once in a while, there's an invention that is so profound that it changes culture. And, you know, there was the printing press. There was the sort of invention of the advance of fossil fuels. And now there's been the computer. And, you know, starting out in the building industry, when we first saw the impact of computers, you know, I'm a T-square and Mayline girl. I don't know how to use a computer for drawing. I never made that transition. But over my lifetime, the sort of impact of computers on our industry has been tremendous. And the early energy modeling tools we had that we used in the days of LEED were really inadequate. And back when I was in school studying with this man, Charlie Brown, my mentor, looking at things like sun angle and heat loss, we would look at very simple buildings and we'd be calculating them all with a calculator by hand. So the computer's really given us this chance to be precise beyond really what we've imagined. And if you've done computer models that are basic, like HAP or TRACE or TRAIN, eQuest, some of those models they're general enough that they're dangerous. They predict performance that we don't see. But the passive house energy modeling and the sort of accompanying suite of tools has been precise enough that we really can see what we're doing. And about 20 years ago, when LEED came on the scene, it was this wonderful sort of index of all of the issues that were related to sustainability in building. And now today, we've had this sort of groundswell. And if you think about all of the LEED points, each one of those is a full professional career. You know, whether you're in land use planning or air quality or energy or water or, the embodied energy and materials, each one of those is a full, career's worth of knowledge. And so how do design professionals like myself kind of navigate this water? And I think that it's really important for us to move beyond the point where we're thinking about getting the next big shiny plaque. And we're thinking about taking the performance metrics that rating systems like Passive House and Reset for Air Quality give us. And we need to actually sort of, rather than make our projects be special, we have to normalize this kind of practice. So we can take the targets from the existing rating systems. We can take, water quality monitoring from well. We can take air tightness and air sealing from Passive House. We can take air quality targets from Reset. And we can use those targets as the metrics that we designed to, sort of bypassing the rating systems entirely, using their wisdom, but not spending the money on third-party verification, spending the money on the monitoring equipment in-house, and then we as building owners can then have the control over their own property and understand if they're in fact getting what they paid for. I think it's really important if you're embarking on a passive house project to have the first people at the table be really engaged in the sustainable measures that you hope to seek. Otherwise, everything is added onto the project and will ultimately be more money. One of the reasons we as a team have been able to accomplish what we have is that we've all drunk the Kool-Aid. We've all got the same goal. Phil's sitting there doing the numbers and thinking about how something can be possible, and we're imagining those things together. In closing, I want to say that the passive house is the way to the future. In Dublin, Brussels, they're integrated into the building code. And in New York, Bill de Blasio has written a treatise, One City Built to Last, where he's endorsing passive house measures as a way to get the city to its energy targets. And these are all projects that are on the board in New York that are using passive house criteria in their design. So challenges from insulating from the inside, I think we've run through those. But I think it's important to realize that we have better candidates than the ones that we're showing you today. We have ugly, poor performing buildings everywhere, a lot of them in social housing. And if we can think about targeting the low-hanging fruit, which are buildings like this, and insulating from the outside, I think we can change the world. We can make old buildings that have a dated appearance and that social stigma that I was talking about at the beginning of the session. We can put a new skin on them. We can transform those neighborhoods. We can save the embodied energy in the buildings, and we can improve the air quality of residents, and we can make those buildings perform like new. We're not going to get out of the energy crisis by designing only new buildings. This has been done in the UK by Mark Elton. This is a project, social housing. You can see that's what it looked like. This was done with residents in place. Residents in place, he put a new skin on the building. He put a level of shopping down below. So that improved and revitalized the community on the street. He gave the project a new look, and voila. So we need to find the right candidates for this kind of renovation. We need to set our targets. We need to measure the results. And we're on track as a nation for doubling our existing building square footage by 2060. That's the equivalent worldwide of building an entire New York City each month. We really need to turn our effort and our energy toward existing building stock. I look back at this photograph and I wonder, how did this happen? And it happened because we had the idea that illuminating things at night was a good idea. And we did it as a community. So if we start the ball rolling and we capture these energy savings, we can do it. We can renovate each building one at a time. 5 minutes left, okay. I could tell by Stan's body language that he's getting nervous about time. We're almost done. So natural order of sustainability. You've got to use those passive measures first. Everybody thinks that solar panels are the way out, but the problem is you can see this house that I photographed in South Carolina, which is not showing well on the screen, but this guy has, can someone dim the lights back there? Can you maybe turn the lights down? This guy's got solar panels. He's got, I don't know if you can you see him?
Oh, you can see them sticking out, yeah.
Yeah, well, anyway, he's got solar panels all over the place. He's got so much air leaking through the skin of his building that he can't fit all of the solar panels on the roof of his project. And so he has to put them all over. He's got them on the garage. He's got them standing up in the yard. And I thought it was a wonderful way of demonstrating it. This building on the left is the first net zero building done by David Orr at Oberlin and Bill McDonough. And they thought they were going to get there using solar panels, and they had to build an entire parking lot that has an additional solar array over it so that they could meet their zero targets. So air sealing first, active measures second, and renewables last. And then this is our next project that we're going to make a plug for. We're not doing a retrofit next time. We need a break from that. But we're going to try and be net zero. And the way we're getting there is by making that really tight envelope and then adding the renewables and getting us to zero. Thank you very much.
We do have time for some questions.
Can you talk a bit more about why spray foam was preferred to a sealant and the concern about brick failure at the first building?
Yeah, so existing brick is used to being heated from the inside out. And in one project that I did that was a homeless shelter, the surface temperature on a 25-degree day in our thermal images was 57 degrees. When you put a fluid-applied membrane on, you're sealing the transmission of moisture and the possibility of it moving through the brick. And even though we're using the spray foam and we use closed cell spray foam as an air barrier, there is still some air that migrates through. It's not a perfect air barrier. And we believe that's where our buildings are not making the passive house metrics. But we're still saving the energy. So we'll take that. We've been advised now by several envelope consultants that if we went to a fluid applied product, we would risk, because of that slight amount of air moving through that brick, we'd risk popping off the faces of the brick when it got too cold outside. And that's just something that we've been too nervous to try. You know, we as a team have talked about aerogel, but again, I wouldn't touch something like that without a building scientist on the team. I'm not up to snuff to be able to say. And I don't believe there are many architects that are. Other questions? You had one.
For the dryers, did you use condensing ventless dryers or traditional?
We didn't. We just used traditional dryers and took the hit. I think that, you know, the drying manufacturing industry is not up to producing the product that we need. And we as a team feel that if you put something like condensing dryers in a project like that, you're going to really enrage everybody's wrath. So we find ways to model around the laundry room to avoid some of those issues. But we don't have the equipment that Europe does, and we don't have the culture. People aren't going to stand and wait for their clothes to be dried in, you know, an hour and a half when they're used to having it do in 30 minutes. So those are the kinds of things that I think we have to be careful of culturally when we are pushing the envelope.
Did that mean the passive house envelope did not include the laundry room? Or?
No. The passive house envelope included the laundry room, but we had special ventilation. We isolated the ventilation in that room. We brought in extra air and we took the energy hit, but we isolated it in terms of that equipment.
Talk a little bit about the premium and pre-construction cost on a retrofit.
Pre-construction, so soft costs, that's a good point, because, you know, I always want to put on our best face, but if I'm being really honest, the additional costs that are associated with passive house, it should be mentioned, do include soft costs. It costs more to design buildings like this. You need an energy modeling person, you need an envelope consultant on a project like this. Or if you're on your first passive house project, it would be, you know, that was of some scale, it would be a good idea to have a consultant. So it does cost more to design these projects, and frankly, we took a hit in terms of our fee on these projects. You know, we weren't compensated well enough for the time we put in, but I think given what they contribute back, it's money well spent. But without a doubt, I think, and I think that's the future of sustainability, we're going to be spending much more in thinking about the project in the upfront stages, thinking about testing it, modeling it, and designing it more carefully, and then holding the construction team to their feet to the fire in terms of making sure that we're building what we said we were, and then being able to monitor it on site. I think that's the wave of the future. I mean, I can't imagine why big developments aren't going to want that. They're going to want that capability in-house. And monitoring used to be hugely expensive, but the cost of that is coming down so rapidly that, I think that air quality monitoring, Victor, what do we pay for all of that? Was it like $5,000 or something?
Yeah, that's around there.
Yeah, so, I mean, it's not, in the scheme of the project, it's not very much money at all.
Well, you skipped over the existing building survey, which I know you guys never liked, but, if that's included in the architect's fee. In a rehab, there is a higher percentage fee an architect can charge of the PHFA project. Sometimes the existing building surveys are costly. They can be, yeah.
They are, just recording those existing conditions,
Yeah.
it can be a big hit right up front for us. Any other questions? Yeah?
For the passive house envelope, he explained it when doing it on the interior, working from the inside out. What if you're doing it the way you suggested, when you're building out the building, the structure, where you're building from the outside to get your passive house? How does the envelope, how is it sealed, you know what I'm saying, to the foundation?
Yeah, so imagine that it's just like, when you're insulating from the outside, it's just like putting on a sweater, right?
Right.
Or like a snowsuit. And so you can put your air sealing on the outside, you can put your thermal layer on the outside, and you can put new cladding all on the outside.
What about the foundation, how does it tie in? 'Cause
Well, the foundation's tricky, but as Phil was saying, he built a new project where you didn't need under slab insulation. I've done a retrofit where we didn't have under slab insulation. It just wasn't feasible to do. We did it at Morningside because we had the head height, and I've done a couple of projects where we'll put a new floor in, there'll be an existing concrete floor, we'll put insulation down, then we'll build a new floor over it where we have the dimension. But, if you don't have the dimension, then you can model around it. And it's one of the nice things about modeling. You can say, okay, we're taking a hit on the under slab insulation, but we're going to beef up, our wall insulation to compensate. And so as long as your system is still working in the model, you can play around with it. You can value engineer that way too, So under slab insulation is expensive. We want to pull that out. Let's add a little bit more roof insulation. And you can work with the contractor and figure out how to make your budget pull into line. Other questions?
I'd like to add that the building that is lacking under slab insulation is a certified passive house.
Right.
Yeah.
And everybody's comfortable, I bet. Yeah,
No,
yeah,
Yeah.
yeah.
Could you talk just for a minute, I mean, one of the things you said that I thought was really interesting is you were speaking of basically taking the design criteria from these various programs and sort of deciding what building you wanted to model to, and maybe cutting the verification end out, and then you mentioned certified passive house, made me think of that. Are you concerned at all? I mean, one of the things I kind of saw being in this industry was when LEED first came about, it was very expensive to comply with, and these products just didn't kind of exist in the marketplace yet. And we started to hear a lot about sort of LEED certifiable as compared to LEED, and what we saw is those buildings were of far inferior quality. It's easy for the wrong set of contractors and architects and developers to sort of wave their hands over a number of those requirements. Is that a concern, or how do you reconcile that concern, I guess, with what you're saying?
Well, I've thought a lot about that, and I agree with you. I mean, you can't, but that's not a construction issue, that's a moral issue. Are people lying and cheating and stealing? Yeah, they are. Do I wish that was happening? I wish it wasn't, but it is a fact. For me, it's much more, I've come down on this side, so, and I want to be clear. I think it's really important to do the kind of performance testing that Phil was talking about. I'm not suggesting not doing a blower door. I'm not suggesting not testing to make sure that I'm not talking about commissioning, for example. I think you need to commission your equipment to see if it works. But I am suggesting that it costs an awful lot to make sure that you ticked off every box on, the rating systems. And many of the rating systems, you look at the cost of well, and you're really talking about a significant increase in cost. And so if we keep as a culture making sustainability the specialized case, how are we ever going to make it the norm? We kind of keep making gold stars for ourselves to reach for, but we're not sort of translating it into best practices. So my push is, don't deal with unscrupulous people, right? Do your best to avoid them. Pay a little bit more for reputation. Maybe you don't bid every job. Maybe you negotiate with someone that you trust. You bring someone to the table, you tie their bonus to performance metrics that you monitor in your building. I think as a culture we need to come to, I don't think we can police everything through a rating system. And I've even heard about lead buildings where certain people were influenced by others. So corruption is rampant in our culture, and we can't tie those two things together. We have to separate them out. And that's the conclusion that I've come to. And construction's tough. I mean, Phil's a good guy, Leo's a good guy, but there are lots of not so good guys out there. And I think that we need to really be able to, the owner needs to be able to verify and measure on site. See if they're getting what they pay for.
Yeah, I think PHFA does some verification. I mean, we were concerned on both these passive houses, the Glassport and Morningside. We have a schedule we have to meet to deliver the building to the investor, and Phil used the word downward adjuster. It's good when your contractor knows what a downward adjuster is. But at some point, we're chasing these holes in the buildings, and we have to realize, well, is this going to cause the performance of the HVAC system not to work right? No. We could spend another $100,000, and it might save the project, $1,000 a year in costs and energy loss or whatever, So you have to kind of make these decisions on the fly with your contractor. Are we going to, as long as we're going to be within the tolerance, we don't like the fact we didn't make our goal, but I mean, how much are we supposed to spend? This is affordable housing.
Right.
It becomes a.
Well, and it's important to realize that those rating systems are relatively arbitrary, right?
Mm-hmm.
Somebody sat in an office and they thought about, okay, what's the best number? But what's the best number at Morningside? It's probably different than the best number at Hillcrest, and it's different than the best number at South Hills, because all of those have particular constraints, and that's the problem with rating systems. They're great to set targets to. They're great measures, and we need those measures. But at a certain point, we just have to do it because it's the right thing to do. And we can't wait anymore. Time's up.
Yeah.
Speaking of time's
And there we go.
up. Just about that.
Thank you very much.
Thank you.